So this video shows how Glejser's test can be performed via JASP. So the basic logic of Glejser's test, it means the test which is detecting heteroscedasticity in data is based on following formula. You would compute absolute values of residuals and it would be as a dependent variable in new regression equation, and original independent variables will be included into this regression equation. The evaluation of Glejser test, it means detection of heteroscedasticity is based on the evaluation of coefficients for this regression equation. It means residuals regressed on original independence. So the first step is that you need to somehow compute these absolute values of residuals and then implement a regression equation. As JASP is not capable currently to save residuals or even absolute values of residuals directly into data matrix, we need first of all to take previous computation. So it means this is the intercept, the value of slope for size of the flat, and slope for flat new versus old. So these coefficients should be taken as the base for the computation of these residuals, and computation intercept plus C size multiplied by real size and new multiplied by 0 on 1, whether a flat is new or not, should be subtracted from original price of the flat. It means from the first column in my data. So here we have a copy of intercept C size and new slope. So now we need to implement this computation into data matrix. We will use computation of the new column, so it means this plus which is on the right upper corner of data matrix, and we would call this new variable, it means it is absolute values of residuals, as ABS instead of absolute, and RES as residuals. Instead of just clicking platform, we would apply computation in R. It would be easier, so it means it would be necessary to implement R code, but it is only simple equation, so I guess you would understand the meaning of this expression. So I would click into R. Currently, scale variable should be computed, and we can click into create column. So now here we have the open window for R code, so it means it is expecting I would take price and subtract intercept C size multiplied the real size value and new multiplied by zeros and ones according to columns C size and whether the flat is new or not. Only be careful, R code as well as JASP is case sensitive, so it means big letters and small letters in variable names must be correctly defined. So I would type as the first price, and I would subtract the value of the intercept. So this is the value of the intercept. Then I would subtract the impact of C size. So it means C size coefficient multiply, it means star, and I need to type C size by small letters. So C size by small letters. And I would need also to subtract last part. It means coefficient for new flat, and multiply one again star and type new with small letters. So this is residual. Real price minus estimated price by my regression model. And as far as I would like to get absolute values for these residuals, So I need to take the function ABS, which is for absolute values in R, as well as, for example, in the Microsoft Excel environment. And I would need to take brackets, the beginning and the end. So this should be expression. Let's compute absolute value of difference between real price and estimated price by my model, or in other words, let's compute absolute values of residuals. So that should be a correct formula. Click into compute column, and it seems it works. So for the first flat, the difference between real price and estimated price is approximately 75,000. For next flat, it is approximately 33,000, etc., etc. So it seems it works. And we have just defined absolute values of residuals. And now we would perform a regression model with C size and new, but my dependent variable wouldn't be original variable of price. We are not computing substantive regression, but we would like to find whether residuals in absolute values are somehow related to our independence. So it means that my dependent variable would be this new variable we have just computed absolute values of residuals. So I would go back here to my regression. I would take once again copy of my multiple regression without interaction model. I would click on plus. And I would only exchange dependent variable. It means I will replace price variable by my new variable absolute values of residuals. So I would only change the title for this analysis. So it would be Glejser's test of heteroscedasticity. So here it is, and I would replace price by absolute values of residuals. So here it is. I would only wait a minute, and here how it works. Maybe I will slightly only change statistics. I don't need collinearity diagnostics for these outputs, so I can make these tables shorter. And once again, absolute values of residuals related on independence. So here we can see coefficients, and here we can see statistical evaluation. And the rule for Glejser's test is following. If some of these coefficients, it means relationship between C size or nu, and absolute values of residuals, which is my current dependent variable, would be statistically significant, it means there is heteroscedasticity in my data. If none of these variables are related to absolute values of residuals, there is no heteroscedasticity. So I can see that p-value for both of these values, for C size as well as for nu, are related, at least at 0.05 for p, to absolute values of residuals. So it means not only our previous picture, it was present here, that was some idea based on this picture that maybe heteroscedasticity is present, but currently by precise testing, we have discovered that heteroscedasticity is present in my data. Once again, if I would like to solve it, so the solution would be to apply weighted least squares. So it means in a regression, we would apply this window for some special weighting variable. And we should need to compute some weighting variable, which would be usually 1 divided absolute values of residuals. So it would be analytical approach we would apply for this heteroscedasticity case.